Hello, Internet. I wanted to have my cat in frame since she's hanging out, but I don't know. Maybe not. Also, you see, there's something up with her nose. I'm taking her to the vet soon. I rubbed it off. It seems like it's a scab. And I'm like, how do you get a scab above your nose? It's been there for a while. At first, I thought her nose just got a funny color, but anyway, we're going to the vet in a week. But yeah. Anyway, since I had made a video talking about how bugs can happen, I thought I would make a video about how people try and prevent bugs from happening, or catch them and correct them, before they get out into people's, the end user's hand, the game player, the website user, whatever. Um, and as I was thinking about this, I mean, there are at every step of the way, from a project's conception all the way to when it's launched, there's a bajillion things that you do to try and prevent bugs. And I realized in thinking about it, one of the things I missed at kind of the top is just having a good estimate of how long the thing is going to take to make, right? Because there's only so much money and time in the world. And if you've ever, played a game that on launch was full of crazy bugs, like, I don't know, City Skylines 2 is a recent example, or was just missing all the features you thought a long time ago. Why am I blanking on the name of this game now? No Man's Sky, right? People were like, where are all the cool features we were promised? Where did they go? The problem is someone promised way more than could be delivered, whether that was to the public or just internally, right? You said, hey guys, we've got a year. That's how much money we want to spend, right? There's a bunch of people who are going to work on this. It's going to cost that many dollars. Eventually, we need to launch this thing and start selling it. So how long are we going to take, and what all do we want in there? And if you stuff way more in there than you've got time for, something's going to go wrong, right? Either you don't deliver all the things that you promised to people, or you delivered them but they're like really buggy. And hopefully, right, that's probably pretty obvious, right? That applies to every field. It doesn't matter if it's programming or building something or cooking something. It doesn't matter. If you have to take shortcuts, things are going to suck. So one of the first things you do to try and prevent bugs, because no one wants to launch, right? Companies aren't aiming to launch with a shitty product because that's not going to do them good in the long run. They want to estimate well to so that they can have something that, yeah, everyone knows is like, great, this is what we expected, we can sell this or whatever. And even if you're just an individual, like I've got my side projects, right? There's only so much time. I've got X number of hours after work and before I go to sleep. How am I going to spend that time? What's the most important thing? For Popseed Pets, I've got a bajillion ideas coming in from players. I can't program a bajillion things. I can only program, again, right? Only so many things, so you got to prioritize. Or never ever launch, right? Which also is not the goal. You want to get your thing out eventually. So at huge companies, it's a little different. When you've got projects that span multiple departments and have tons of connections, estimating gets crazier and isn't something I have done. At smaller companies, I have had the role of project manager. Even if that wasn't my title on paper, those were the roles and responsibilities I had. It was to gather the requirements, what do we want to build, and produce an estimate. Can we build this? How will it be done? How long is it going to take? How long do you want it to take? My boss, president of the company, whoever, right? What's our timeline? Because again, in that scenario, you got to get something out. We can't just pay developers forever. So for a small team, I know how it's done. For a large company, I don't. So for a small team, you get the requirements from the end user. From the end user. Well, maybe. It depends. You could have lots of people, lots of stakeholders, right? Lots of interested people. Maybe it is feedback from players who want to do stuff. Maybe it's the marketing team who says, this is how we're going to sell it. Maybe it's the owner who just has a vision, whatever. So you've got different people, whoever they are, and they give you the requirements. When it's a lot of people like that, it's more fun, because then you have to negotiate with all these people, right? This guy says he wants that. This lady says she wants that. Are they the same? Are they compatible? Whatever. So that's another aspect. But let's just talk about the estimating. So when it's smaller and it's in those situations, I was both project manager and programmer, and so I was able to do both, which has pros and cons, both the estimating and the development. The advantage here is that I can go to a person and quickly kind of break down, right? I can take the idea, say, okay, you say that you want a button on a page. When someone clicks it, it's going to send an email, and maybe we're going to collect some information about the person that they entered on a form, whatever. Let's say it's a form. Get in touch with us form. It's going to have who are we from, here, what's the information I want, here's the button to click, it needs to send an email. Okay. So the first thing you can do is like, here's the requirements. Great, let me get back to you, person asking for that form. And then I would break that out into individual like work items that someone would do, a ticket, a story, whatever. And those could be different things or the same things. It depends on where you work. And so that might be something like, okay, I need to hook up the email service. That's going to be one of the items I need to do. At the same time as that's happening, someone can start building actually the visual form, the web page, and then finally we're going to need someone clicks the button and it sends that email. Okay, we're going to need a little bit of software in between because it's going to be this web page. It's going to talk to that piece, and that piece is going to send the email. Okay, so here are my 3 tickets. Let's say. Then what you would do, and here's another thing where if I was the only developer, it's better if you've got a team. So let's say you've got a team of, could be a team of just 2 or 3 people. Let's say 3. So I would take these things and say, how hard do you guys think all these items are? And you don't estimate in time, you estimate how complex is this task. And it's on a Fibonacci scale of numbers for reasons. Well, one of the reasons is, let's give this example for estimating. If I asked you to estimate something and you said, it will take me 1 day or 2 days, I'll believe that you know the difference between 1 day and 2 days. If you say this will take a month or a month and a day, I'm going to be like, how do you know the difference between it's going to take you a month versus a month and a day, right? Or if you said a year and a day, right? Like that's obviously nonsense. So when you estimate the complexity of tasks, it's similar. You have a bunch of small numbers, but they start to space out because the bigger the numbers, the less certain you can really be, the less accurate your guess. So when you estimate complexity, they have it be on a Fibonacci sequence. I don't know if there's a reason why Fibonacci numbers are better than like powers of 2 or something, right? Just 2, 4, 8, 16, 32. No. They say let's do 1, 2, 3, 5, 8, 13, 21 for whatever reason. So you estimate complexity that way. What's the point of this? Why are you estimating complexity and not time? A, humans suck at predicting time. And actually, I think that's the main reason. B, humans suck at predicting time. So what you do instead is you and it takes a while for a team to get going. But as a team works on these tickets where they have estimated the complexity, this is going to be a 5. That's kind of difficult. Oh, there's a 1 or a 2. It's super easy. If it's something really big, you might break it up. So that's another thing. If something is so big, you're like, I can't even imagine how hard it is. It goes beyond a 21. Then you say, well, hold on, we need to break this into smaller parts so that we can estimate them. And then as a team works week after week after week, you get a sense of their velocity. How many points are they getting through every week? And that can vary by project and by team and by all kinds of things. Like just because one team says something is a 5 doesn't mean it's a 5 for another team, right? So, I mean, a good example would be, what if on your team you have people who can do the front-end design, like this form we've been talking about? Then they might say it's very easy. But what if they don't? What if they have to reach out to another team or like grab this other designer, right? As soon as you add another person they have to start talking to outside the team, it's harder. So you're going to say, that's like an 8 for us because we're going to have to reach out to someone. We're going to hope to get his time. We're going to have to communicate these ideas somehow. There's going to be meetings, right? Whereas if it was all within the team, you're all on the same page, you'd say, yeah, it's easy, it's a 3, I'll throw that together, right? So the same task can be different values for different teams. And as a team works, you get a sense of this velocity. So that's where the estimation comes from. You say that a team gets through like 90 points every 2 weeks. Usually you break these chunks of work into sprints of 2 or 3 weeks. But 90, great. You say our team can do 90 points every 2 weeks on average, plus or minus 10. So now we've taken this estimate. Here's this form we need to make. Setting up the email service. We don't have one of those, let's say. So we're actually going to need a little bit of research first. So we'll have a dev research it. He found out, okay, there's these 3 parts. One of them is a 3 and a 2, and another one's an 8. Okay, whatever. Okay, the front end design. We have someone who can do that. He says it's like a 3. It'll just take him a few hours. He's not supposed to think about time, but that's what he said. He said it's a 3. People are inevitably going to talk about time, even though they're not supposed to. And then, hooking the little in-between hookup, the other dev said that's a 5. So you add that all up, you get whatever number you get, and you say, great, we can complete that in X amount of time because we have this sense of velocity. The velocity numbers can get wacky for a team, right? As people come and go, if you have churn within a team, that can throw the estimates in all kinds of different directions. If there's a lot of bugs can be hard to estimate. I mean, right? If a bug comes in and you're like, well, how hard is it to fix the bug? You're like, well, we don't know why the bug is existing. That's why it's a bug, right? If we knew, we would have done it and we would know the estimate. But I'm just going to take a bunch of time to even find the bug and find out how hard it is. So if you have a team that works on a lot of bugs, you sometimes use a different, you don't do the point thing because the points can be hard. But anyway, what was all this about? How do we prevent bugs, right? And this is the first thing you do. You try to get a good estimate, and there's a lot of things that can fuck up that estimate if you've got a lot of churn, if you just don't have experienced people, if you're doing something brand new where people just don't have a good sense. They're like, I don't know, how hard can it be to set up an email thing? 3, and then someone looks into it and goes, uh-oh, actually it was much harder than that. We've never done this before. So, right, a lot of ways it can go wrong, but if you have an experienced team and you're building something fairly familiar, there's always going to be something new, a little scary. You can get a pretty good estimate using this method of points and everything. And this is at the heart of the Scrum and Agile process in software development. I'll put links to some of these things in the bottom. So anyway, that's kind of the very beginning, right? Get a good estimate. That will prevent bugs. That was a lot of explaining. I probably could have saved that whole thing for a different video. This is already 11 minutes. But that's okay. Let's keep going. So next thing, developers are working. As a developer, there are ways that you can program to create less bugs. So I showed this example. I've been using this a lot of times. Here's my little function that adds a couple numbers, right? And you can, even if you don't know a lot of programming, it's pretty clear this is self-contained. There's nothing outside or this function that you need to know to understand. You have an A, you have a B, you add them together, you return that value out to whoever asked to add, right? Here's your A plus B, done. What if you wrote something like this instead? A plus B plus C. And you're like, well, this function gets A and it gets B. Where the hell does C come from? And you might think, maybe if you don't know much programming, you're like, well, this is impossible. Your computer wouldn't accept this, right? It's like, no, it could. This C could be defined somewhere elsewhere in the code outside of this particular function. This is kind of a weird example. No one would probably write this. Actually, there are reasons you might write something like this. A more interesting example is something like time. So it's very common in code. You might want to know how old something is. Is something past due, whatever. And you can just ask the computer, hey, what time is it right now? And so if you have on record, this thing expires on the 3rd, and you ask the computer what day it is, and the computer says it's the 4th, then you say, great, that was in the past. Therefore we are past due. It can become a problem to just always ask what time is it inside of a function, because the time is something that didn't come into you. It's just this other thing that exists out there somewhere, and it's changing all the time. In a lot of cases, that's fine. In some cases, it makes this function a little more complicated, though, right? When you're trying to debug this, you're like, oh, it depends on what time it is right now. And again, that's pretty intuitive to think about. We're humans, we deal with this a lot. But it's another variable. And there are cases where we'll talk about testing more later. Right now, we're just talking about writing this code. But when you're testing this, if you want to write like a little bit of code to test for you, how do you test past due if you can't control the time? You always have to control the due dates. You can never control the time because you're just asking the computer, what time is it right now? What time is it right now? So whenever you run your test, it's just whatever time it is right now. So having any kind of external dependency like this makes things harder to work with, harder to reason about as a person, because in this example, you'd be like, well, where is C defined? When can it change? What is its value? For these ones, it's very clear when they change. It's just when they said add 3 and 4, then we added 3 and 4. But again, where is the C? How did it get set? So avoiding this scenario is a very useful way to prevent bugs. And there's a ton of stuff like this. It's just like one thing out of a billion like concepts in architecture, right? Software architecture and software engineering is this would be generally be called reduce the scope of your variables, to use all kinds of technical words. But there's a lot of things like this on how you architect code. And this kind of goes back to what I was saying before. There's a million ways to solve a problem. Some of them are just harder to think about, harder to reason about, and if you can make your code easier to reason about, then that's easier for people coming in later to debug issues, to make them all kinds of things. Well, not always to make them. Sometimes the easiest way to make things is a bad way for in the short term, right? You can do a bad way that's really good and easy in the short term, but bad in the long term and bad variable scope. And I see this kind of stuff all the time. I'm trying to think of a better example in date time, because again, humans are pretty good about reasoning about date time, but hopefully this gives you a sense of there's all kinds of external things you could just be kind of implicitly requiring that actually makes things complicated. And it might just be one, right? What if it's C, D, E, and F? And you're like, where did all these come from? And you're tracking them down when you're trying to debug an issue. Or you accidentally create an issue because you don't realize, maybe you write this function and you didn't, as the author, properly consider all the ways that something could be changed. It might not be obvious. It might not be code that you wrote. And you think you understand, but then come to find later you didn't understand. So reduce your external dependencies like that. Keep the scope small. That's one way to prevent bugs as developers. Okay, let's say you've developed as well as you could. What's the next way to prevent bugs? There's a peer review process. So after you make all your code, and the way this works, there are branches. I should have had an artist's rendition of a branch, but I mean, I can just whip one up real quick. It's really easy. It's not a complicated process. Imagine all of your code going in a line, right? Developers are putting new things in all the time. You might, for your own sanity as you work, and so as not to kind of run and bump into other people, you make a copy of a code called a branch, and this is where you work. And when it's ready to be put back in, I'm doing it backwards because, again, everything is horrible. And backwards. Then you say, okay, it's time to merge all of my changes back in. And computers will help you do this really fast, right? I mean, you did this to not run into people, so you're like, well, aren't I going to run into people when I do this? I don't know if this is making any sense. You might. Anyway, when you want to do this, when you want to take all your changes and put them back into the main thing, they do not go back in immediately. You have to go through a little peer review process. You get a couple other developers on your team, and you say, please review my code. And it's often required. It will be required by your little system that's tracking all the code changes that often has visualizations like this. It will say, no, I'm not putting that in until two other developers check a little box that says, we approve this code. And that's great, right? Get more eyes on it. And oftentimes you'll have other requirements kind of baked into the system. You can get a little fancy to say, well, if there were any changes to any like user interface code, then it needs to be approved. One of the people has to be a UI person. And if it's like a database thing, well, then a really knowledgeable database person, right? Someone who has the title of knows database shit has to review this. So you can get those rules complicated or as much as you need to hopefully get experienced eyes on these things. Because again, you could be a new dev at this job and you just committed some code and you don't know. So, get your, and even if you are, the code is crazy and huge and maybe 20 years old. Maybe you work somewhere and the code is older than you are. God, that's crazy to think that could be true. So yeah, less likely to be true for me, but depending on your age, yeah, it could be very true. It certainly still could be true for me. There's absolutely programs out there that are older than I am running banks and shit. It's bananas, right? So you have this peer review process. The other thing that happens as you're when you make this little change, I talked a little about how there might be automated tests, right? When we were talking about what about the time. So something else you might do when you suppose you coded this add function is you'd write some tests that say, when I call add with like 5 and 7, I had better get 12. And you'd say, okay, positive numbers easy. What if there was a bug for negative numbers? Okay, if I add 3 and -1, I had better get 2. 0 is also a place where things can go wrong. What happens if you add 0 and 0? You had still better get 0, right? So you might write some automated tests, and you write those in code as well. And then when it comes time to do this, everyone's automated tests are run, not just the ones that you wrote, but everyone's across the whole code base. Because again, what if there's weird things like this C that exists outside? Can I change this inside my function? What if I accidentally break someone else's code? Whoever's code is managing this weird C variable that we don't even know where it comes from. Maybe I wrote some code here and I accidentally, messed with the value of C and I broke someone else's code. Hopefully, that person wrote unit tests so that when it comes time to merge my changes in, all of the tests run. Sorry, I said unit test. Ignore that. Automated test. All of these little automated tests that developers wrote get run. And if they wrote their tests well, which is an if, but if they wrote their tests well, and if you wrote your tests well, then bugs can be caught in that way, right? A little test runs and says, oh, something broke, and then you go and say, oh, how did I accidentally break that? I didn't even know that was related, or I did, but I didn't think I had broken it. Whatever the case may be, a test fails. So that is another way that we catch bugs. Not even finally, but you would then have a QA process. So after we have done all of this, I've done my little we'll call this is called a feature branch. Usually I'm working on a new feature. I made my own little branch of code, right, off of this weird tree. It gets in at some point, and I'll just put in a couple other developers did some stuff too. So, some other people have done it while I was doing my thing. Someone else did their thing. And then at some point, we're going to say, it's time. We're going to make a little branch. And there's other ways you could do this, tags. Don't worry about it. You'd make another little branch and say, this is our release branch. We're going to now test the hell out of this. We're going to split off from this point, test the hell out of it. And if it passes, this is what's going out to people to use, right? And meanwhile, other developers can be working, further down this line. Developers might be working on the next release while this release is getting tested. And ideally, you have different people testing than who wrote the programs, right? The person writing the program, again, we're humans. You have these assumptions. You're like, oh, I fully understand how C works, right? And the unit test didn't catch anything, but someone somewhere along the line was wrong, and so you give it to a totally different group of people who didn't build the thing at all, and they test the heck out of it. And they hopefully think of scenarios that the people developing it never thought of, just because they were just in their kind of state of mind developing the thing. I mean, I don't know, you can probably imagine this in other scenarios too, right? As a creator, it's very easy to just get, I don't know, to have this different vision. I don't want to say myopic, but I don't know what it is, right? I mean, if you cook something, you might say, oh, this tastes great to me because you tasted it at every step along the way, but you give it to someone else and this is awfully sour. Whatever the case may be. Hopefully this is an intuitive thing. You give it to someone else who didn't make it. They test it, and they look for weird issues. If issues are found, they can be fixed. I won't talk about how they can get fixed because it can be tricky with all this branching going on, but never mind that. Let's say issues are found, they're fixed. Wonderful, we finally release. Do we actually release to the public right now? You might not. You might put it out to, and there's a number of things you can do. So for games, it's fairly popular. I don't know if popular is the right word, but it's not uncommon to have a beta environment that people can play in. A lot of online games do this, like League of Legends, MMOs like WoW. I think WoW, Dofus I play, I know for sure they do. But anyway, you can opt in. You can say, I love playing this game. I would love to get a sneak peek at the features coming. I will happily play on your beta server. And this is just managing expectations, right? I know I'm signing up for beta server as a player now. I'm not a developer anymore. Sorry, I've switched to who I am. I'm now a player. I'm like, yeah, I'll sign up. I know there's going to be bugs, but that's going to be kind of fun. I get to check out the new content. Who cares? I'm going to have fun. And if there's a bug, I get it and I report it. Everyone kind of wins, right, in this situation. Another thing you might have seen is programs like Outlook. Definitely, Microsoft is big on this in general. Lots of online things are. Pretty sure Facebook. But you'll see a thing where they're like, oh, you're using the new experience right now. If you want to go back to the old one, press this button and you can go back to the old view, right? This is a similar thing. We're kind of setting expectations. Like, you might not like it for whatever reason. You can go back to the old one for now while we polish up the new one, right? And they're going to get all that feedback. And I think for Outlook specifically, we use Outlook at work for our email. When I say go back to the old one, they pop up a dialog box. It's like, why did you want to go back to the old one? Why wasn't the new one good enough for you, right? So they're collecting that information to fix these up. And it could be that you found a bug. It could be that you just didn't like it. Same issue, you don't like the thing for whatever reason, it's not working for you. So they get all that information so they can go back and fix them up. So yeah, you can. Another thing another way that you can release kind of incrementally is by region. So I worked at a place that did games, and they were like, yes, this is a game that's going to be in English. We're not releasing in the US first. That's our biggest market. We want it to be right when it's in the US, so we're going to release it to smaller English-speaking markets first. Maybe that means, I don't think Australia is the number one. What was the small country? I don't remember, but it'd be like, yeah, Canada, Australia, whatever. Go for the smaller markets, and then go to increasingly large markets as you get more feedback and fix more bugs and all that kind of thing. So that's another way that you might do it. You can also just do it randomly. If you've made a small change, you might just say, well, we'll subject 10% of our users randomly to this change and just see how it goes. Another thing that actually Microsoft does with Windows, if you have Windows Home Edition, you get updates first, which sounds cool, before Business Edition, but it's not cool because they might be buggy. And they're specifically saying, we want our business users to have a better experience than just the casual individual user, so we're going to push our updates to the individual users first. And if they brick a couple computers, well, at least it didn't happen to a company, because I guess companies are worth more than individuals. Hooray. The world we live in. So, trying to go back in time. So I'll do a little recap. So, have a good estimate. do good software architecture, write automated tests, have someone else test it who didn't write it, and then maybe stage your release in some way. Beta servers, where people can opt in various ways, blah, 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 blah. Feature flags is another thing, so just a way for you to be able to, once it's deployed, to be able to say, actually turn off that new bit of code. You can fuck that up too when you're writing your feature flag, but still, that's another thing that helps. So yeah, there's lots of ways that you can kind of protect yourself after launch as well for bugs. So I don't know. I'm sure I missed things in there. There's a lot of ways to try and prevent bugs. And hopefully also, if you're like, why do bugs happen? The fact that we have like 10 plus ways to try and prevent bugs, they happen. They can happen absolutely for so many reasons. And so we have a lot of ways to try and prevent them from happening. So anyway, there's that. Hopefully that was interesting. Thanks for watching. You got to see my cat. What a nice little bonus, I guess. Bye.